Okay, we're just going to work through this whole problem, even though your question's only on D. Okay, so the cost of a first-class postage stamp was 7 cents in 1961 and 77 cents in 2010. So this increase represents exponential growth. So we want to write the function S for the cost of a stamp T years after 1961. So we're basically given the initial value and then 1 point later on in time. So let's see. There we go. Okay. So this is part A. So we know that if it's an exponential growth, then the model is that the price is the initial amount times e to the kt. So we know the initial amount c, because t is the number of years after 1961. So when t is 0, that's 1961. The cost is 7 cents. And I'm just going to stick with cents. Well, actually, wait, let's look at this. Yeah, I think they went with cents. We'll see, as opposed to dollars. Okay, wait, let's look at that again. Yeah, because these coefficients are 7, 7, 0.05, and 0.05. So the coefficient C is 7, so that means we are going to do this in cents. So 7e to the kt. Now I need to find, in order to find the model, I need k. Okay, so that means I can plug in this other point and solve for k. So the price is 77. This is really, should say equals p here. Okay, this is the model I'm using. So I'm going to plug in 77 for p equals 7e to the k times 2010 is, let's see, 40, 50, so 49 years later. Okay, so then we need to solve this for k. So we would first divide both sides by 7. So 77 divided by 7 is 11. So 11 equals e to the 49k. Okay, then we take the natural log of both sides. So the natural log of 11 equals the exponent, 49k. Divide both sides by 49, so k is the natural log of 11 over 49. Now this is multiple choice. Let's see what they've done here. So my exponent is either going to be 77.05 k or 7. So let's just go with this and see what we get. I see what they've done is they've simplified, but well, hold on, have they? No, they all have the base e, so that's fine. So natural log of 11 over 49. Let's see what that is. Okay, that does round up to 0.05, so they're just rounding a lot. Okay, approximately 0.05. So then the model would be p equals 7e to the 0.05t. Okay, so it's b. Okay, then for part B, the growth rate. What is the growth rate and the cost? The growth rate is your exponent k, so 0.05, it looks like what we're rounding to. Oops. Oh, in percentage, so about 5%. Okay. The cost of a first-class postage stamp in 2019. This was in cents too. Okay. So now we're going to use our model to predict the cost in 2019. Okay. So this is going to be part C. So here's the model now. So the price in 2019 would be, let's see, what is that? 49. So 49 plus 9 plus another 9 would be 58 years later. So 7e to the 0.05 times 58. I think that's right. So we need to do 7 times e to the 0.05, no, 0.05 times 58 gets me 127.22 if we round to the nearest penny. Actually, this is in cents already, so the nearest penny is 127. Okay, and the cost of a first class postage stamp in 2022. Okay, so so 58 corresponds to the year 2019 because 2019 is 58 years after 1961. So here, what did I say we're doing? Oh, this is still part C. Okay, so now it's 3 more years later. I want to do this. So then looking at when x is 6 or t is 61. Okay, so I get, that's not right because I did natural log. Okay, sorry, 7 times e to the 0.05 times 61 is, would round up 148 cents. Okay, goodness, 3 more years. So adding 3 more years on gets me to 64. So 172, getting high pretty fast there, which is what happens with exponential growth. Okay, here's part D finally. Okay. The firm will save how much in dollars by buying stamps at the beginning of 2010? Okay, so the forever stamp is always valid as a first class postage on standard envelopes weighing 1 ounce or less, regardless of any subsequent increases in the first class rate. This is nice. You used to have to buy 1-cent stamps. Anyways, an advertising firm spent $7,700 on 10,000 first class postage stamps in 2009. Knowing that it will need another 10,000 first class stamps in each of the years 2010 through 2016, it decides at the beginning of 2010 to try to save money by spending $7,700 on 10,000 forever stamps, but also buying enough of the stamps to cover the years 2011 through 2016. Assuming that there's a postage increase over those years, as we've found here, okay, in 2015 to the cost predicted in Part C, how much money will the firm save by buying the stamps? That's an interesting question. So, what do I say by buying stamps? Okay, so the firm will save by buying stamps at the beginning of 2010. So they're going to need to buy stamps for 2010 in the year 2010, right? Oh, I see. So this, it's currently 2009, they're spending that money. So we start counting in 2010. So if we buy the stamps for years 2010 through 2026, that's a long time. So that is 16 years worth of stamps. They're going to spend $7,700 for each of those 16 years. Okay, so if they buy the stamps now, they'll spend, let's see, $7,700 for each of those years, for each of these 16 years. So 7,700 times 16. Okay, so let's see what that is. So 7,700 times 16 is 123,200. Okay, let's reread this again. If they buy the stamps each year, let's see, assuming there's a postage increase in each of these 3 years, which we've already computed the price for, how much money will they save? Okay, so the cost in, do we know the cost in 2010? Oh, right here we're given, okay. So the cost in 2010 is 77 cents. Oh, wait, was that in cents or dollars? That's in, let's check the units here. 7,700, no, that is dollars. Okay, that's right. So the cost of, let's convert to dollars here. I think that makes more sense at this point, do the whole thing in dollars. So in 2010, from the years 2010 through, looks like all the way through 2019, the cost is going to be 77 cents. They don't actually raise it every single year, and that's what I'm saying. It doesn't look like they raise it again until then. Okay. So for those 9 years, 2010, 2011, 2012, 13, 14, 15, 16, 17, 18, 19. Okay, got to start there. So, what was I saying? So in each of the years from, so in 2010, the cost is 77 cents. So 2010, 2011, if you count this out, 2010, 2011, 12, 13, 14, 15, 16, 17, 18, and, no, that's it. So in those 9 years, the cost is 77 cents per stamp. Okay, so if they purchase later, okay, for the years 2010 through 2018, the cost is 77 cents. So that's a total of 9 years. So how many stamps do they need? They need 10,000 stamps, each at 77 cents. Okay, so 77 cents times 10,000. And then we'll multiply that times 9. So 0.77 times 10,000 is 7,700. Okay, then we'll do times 9 for each of those years. 69,300. Okay, that's for the first 9 years. Okay. Okay, then we're going to do the same thing for the next years. Now I realized when I was counting there that I made an error in counting here. That actually should be 17 years because we're looking at the years, buying stamps for the years 2010 through 2026. Okay, 2010 through 2026. That includes both the endpoints 2010 and 2026. So it's actually a total of 17 years if you count it out. Let's redo that real quick. So 7,700 times 17 would be 130,900. So much they'll spend if they purchase now. If they purchase later, that's the first part of their cost for the first 9 years. Okay, then for 2019, they raised the price in 2022. So for 2019, 2020, and 2021, it's only 3 years. The cost is 127 cents. So for those 3 years, 2021, the cost is, I think $1.27. Yep. Okay. Times 10,000 stamps for each of those, for each year. So 127, 1.27 times 10,000 is 12,700. We're going to do that times 3 years, 38,100. Okay, so we're going to add that to this, and then also, let's see, then the next 3 years, let's see, 2019. So then in 2022, 23, and 24, for those 3 years, the price is $148. At 148, yeah. We're going to do that for 3 years. So 44,400. Okay, and then for the last few years would be 2025, and I think just 2026 was last year. So yeah, just this last 2 years, the cost is $1.72. And we're just going to do that for 2 years. So pay $34,400. Pretty high. Okay, so then we would need to add them all up. And I get 186,200 for the sum. Right there, 186,200. So this is how much they would pay total if they purchased them like every year. They just purchased 10,000 stamps each year. Versus if they purchase them all now, they'll spend $130,900. So let's see what the savings are. Would be the difference. 186,200 minus 130,900. The savings of purchasing now is $55,300. Okay, let's go see if we got that. There's definitely room for a lot of error there, so let's see. Oh, nice. Okay, so hope that was a long video. Hopefully that answered your question though on that problem.